Hello, PreCal students. We have the review today, review section 3.1 to 3.6. And yep, Toots is behind me for all of my YouTube followers who follow me both on Instagram, YouTube,
subscribers,
Twitter. And again, thank you so much. You can also buy merchandise, Coach J merchandise at the website listed at the bottom of the page. Lots of stuff. Lots of stuff. All right, as we begin, I wanted to just go over let's go over some problems with the review, and we'll start on the review. Again, there is an answer sheet that's posted online. Feel free, use that, and we will go from there. Okay, as long as let me see if I can pull this up.
So pull it up.
All right, if we could, hey y'all, we are live on YouTube, so please, I am asking in all seriousness to help me out on this. So we will start with some questions as we move forward. Again, if you have anything, throw it up there, and we'll talk it through. So number one. Ooh, let's start with number one. Very good. We'll start with number one. All right, 3 to the 5x plus 1 equals 5. All right, so any strategies that y'all would suggest in the peanut gallery, how I could change that to a log form? Yes.
I'm feeling we should change it to a log form.
I think that's a great thing. I think we got to put the log in, okay? So how can I change that to log form?
Push it real good.
Good.
3 to the 5 equals 5x plus 1.
Good. That's Toots all the way
That's
from Lake Lanier there. Okay, we got 5x plus 1 equals log base 3 of 5. So how could I solve for that x now?
-1.
Okay, I could subtract 1 and then do what? Okay, subtract 1, divide by 5. But before I do that, I got to solve for log base 3 of 5. How? How could I do that? Yeah, we could do the change of base formula, right? Change of base formula where we get the log of 5 divided by the log of 3.
Oh, wow.
All right. Now we can subtract 1, and then we can divide by 5. Okay, so if I divide by 5 here, then you'll take log base 5 over log base 3, subtract 1, divide by 5. Toots?
Coach, would you mind going over how you got the division there on the right side?
Oh, I made it to log base 5 over 3?
Yes, sir.
Or log of 5 over 3?
Right.
Well, remember, anytime I have a log base 3 of 5 or anything that has a base in it, I can change it and solve for it by doing the log of the outside divided by the log of the base. So that's why we would have log of 5 divided by log of 3. And
Question.
then we could go.
Those logs don't cancel. You have to plug it in to get that, right?
So
Correct. Yes, you have to actually plug that in to get the value. Say that again.
What'd you find last?
Well, you'd have to plug it in your calculator, right? So log of 5 divided by log of 3, subtract 1, divide that bad boy by 5.
Bad boy.
Yep.
Bad boy.
And we would get x equals, does anyone?
1.46 or 7.
1.46. What's the third one? Let's go to 3 decimals.
Subtract 1.
You
have to subtract 1.
Oh, okay, you haven't done that yet, so
my bad.
0.093? Excellent. So 0.093 is the approximate value of what x would become. So what we did on that was we had to use our calculator to solve in that way. If you look on the back there, on number, I think it's 20, or no, not 20, number 17, we can actually do the change of, we can actually change that left side to where it has the same base as the right-hand side. Maybe, so like for 16, we could say 16 was 2 to the 4th power on number 17. So it'd be 2 different strategies in solving, but again, we're still trying to get the same result that's trying to solve for x. All right, numero 1. Very good. My YouTube followers, my friends, my compadres, anyone else? You want to throw it up there?
Don't make me say 2.
Actually, that's what I'm thinking.
Is there an answer key?
There is an answer key online. You go to the haiku page underneath the main chapter right there. This video should be posted right underneath that.
You went number 9.
We can do number 9, and then
Let's
we
do
can come
9.
back to number
Let's
2.
do 9.
Yeah, I'm feeling 9. That's a good one. This one slapped your mama good. It's good stuff right here.
See, that's where you go wrong.
Somehow it's sugar free. So we like hear that and like report you.
No, that's not what I mean. YouTube followers, please. Okay? It means it's good.
Southern slang.
Yeah, Southern slang. No, that's not even, that doesn't help. That doesn't help.
Southern
us say
slang.
that. All right, so if we have the 5th root of something, if we have the 5th root of something, we could take that 5th root and put e to the 3rd x to the 1/5 power. What can we do with that 1/5?
Negatize it.
Now we don't have to, if it was on the bottom, like if it was on the bottom one over that, yeah, we could make that negative. Yeah, we just need to move it to the front. So we'll take a potato gun, shoot it to the front, and so now we have 1/5 ln of e to the 3rd x. Now when I ended up grading those quizzes, you'll notice that the quizzes were pretty good. Okay, we did pretty good on them. But the one thing that we did not, or that we failed to do across the board consistently, was being able to expand this. So we stopped. A lot of people stopped at this point. Instead of saying, all right, I know e to the 3rd and x are separate, being multiplied. What can I do to expand that specific value inside? What can I do here?
Hey, you gotta add them because it's multiplication.
That's right. Good job, Caleb.
Can you just move that 1/5 to the front just because, or?
Well, because what is, remember the exponent rule, right? If you look at the 1/5 or the 5th root up here, right?
Okay.
That means that it's applied to the e cubed x, that all of that will then be to the 1/5 power. So that's when we can take that 1/5 with exponent rules and shoot it to the front. So now if the 1/5's on the outside, we'll just apply it to, when we expand it, 1/5 ln of e cubed plus 1/5 ln of x.
So when
Trey, Q, right?
You couldn't simplify it anymore on the left side, could you? With ln and e, or
We could, right? What could we do?
could you bring the exponent to the front?
Yep, so if we shoot that 3, is that what you're saying, Parker? Yeah, so we're going to take that 3, shoot it to the front again, right? So we've got 3 to the front. 3 times 1/5 would be 3/5 ln of e plus 1/5 ln x. Well, can we go any further? Go ahead, Parker.
I'm just wondering. So when you take the 1/5 to the front, it automatically takes out the square root.
Bingo. Remember, if I have the square root of something, it's the same as saying it's to the 1/2 power.
Okay.
So this is the same thing. We're just saying it's the 5th root. That's why we have to the 1/5.
Question.
Answer.
When you multiplied out there at in your 3rd line, you've got 1/5 ln e to the 3rd x. Why did that x not go behind after the ln e? It would be like 1/5 ln e 3x. All in total.
Well, remember, these are multiplied, right? So to break them up, okay, break up, right? The e cubed had a promposal, whatever you say, for x, but they broke up, right? They want to expand. So we got e cubed. That was a dumb analogy, but we got e cubed here, and then obviously now, because they're multiplied, we do the addition rule.
We're just breaking them up.
Exactly, we're breaking up.
Doesn't
Yeah.
the ln and the e cancel out on the bottom to the left?
That's exactly right. I was going to ask that. ln e here, because it's ln of e, it has the base of e. These cancel, a little cancel party here. Get the donuts out. And now we have 3/5 plus 1/5 ln x as my answer.
Can you combine
Not too
the
bad.
3/5 and 1/5? Or is it a no-go?
What do y'all think?
The 1/5 has the ln x attached to it.
Exactly. Good job, YouTube. I know YouTube followers are yelling at the screen. Okay, nicely done. 3/5 plus 1/5 ln x cannot be combined. You keep that as is
Cool.
because the ln of x.
Very good.
All right. Next one, numero. Number what? Someone say 2 earlier? 14. 14? We go over
We jump
14.
around?
Yeah, I'm down.
I'll jump around. Jump around. We're good with that. We're good with that.
Does the answer key have solutions also?
It does. Yes, it does. It has everything. Really should be everything you need there. All right. So x squared minus 4x equals log base 2 of 32. Thoughts on this one to solve or be able to figure out or simplify this specific expression?
Could we shoot the 2 over?
Okay, we could shoot the 2 over.
That might be going backwards though.
If we change it to exponentially, we could actually do that. But that means we'd have x squared minus 4x as an exponent.
And that's not fun.
Well, not necessarily. We could still do that. In fact, let's do it. If I were to do that, if I shot the 2 over, I'd have 2 to the x squared minus 4x equals 32. So what do I do with 32 to have the same base
Oh, yeah.
as 2?
That's 2 to the like 5th.
That's it. Yeah, I think it's 2 to the 4 or 2. One more. 2 to the 5th. 2 to the 5th would be 32. So 32 could change to 2 to the 5th, and this would be 2 to the x squared minus 4x.
And then you would get 5 equals.
That's it.
All right, so I was
Zinga.
on the right track.
You're right. Yeah, no, you're good. X squared minus 4x equals 5. Subtract that 5 to both sides. X squared minus 4x minus 5 equals 0. What 2 when factored equals negative 5, but when added gets me to negative 4. Yep. X minus 5 and x plus 1. So what is x equal to? Negative 1 and 5. Very good.
Where does the 2 go over log 32? That just like part of it. I saw how you
Right here?
I saw how you went from 2 to the 5th. Did we shoot that to the front?
This right here we changed from here to exponential form. So if we do that, the base of the log is the base of our exponent on the other side. So 2 to the x squared minus 4x is what we changed that to. Word. All right. Next one. Number 2. Did someone say 2?
I'll go with 2.
We'll go with 2.
Why not?
Hey, YOLO. YOLO. That's all we got to say. All right. Number 2. We know it's a compound continuously, so we know we could keep our equation as A equals PE to the RT power. So our principal would be what? 3,000. Yep. E to the R is our rate. We don't know. But what do we know about time in our A?
7 years.
Yeah, exactly. Good, Colin. Good, Samuel. 7 would be T. And so what about our A?
6,000.
Yeah, why do you say 6,000, Kill?
Because it says it'll double in 7 years.
Yep, you're right. So if we're doubling in seven years, that 3,000 goes right straight to 6,000. So we know that it's got to be double that. Again, you could put 2P there, but since we know the principal is 3,000, we could assume it's the A is 6,000 for what we're trying to solve. Yep, you're right, Chris. And what do we get on the left side?
2.
Got dose on the left side. 2 equals E to the R times 7.
Ln it.
Yep, ln, little kryptonite action. So we got ln of 2 equals 7R. And if we find what the rate is, we divide by 7. So ln of 2 divided by 7 will get me what the rate is. All right, just throw that down in your calculator. The rate would be?
0.0, well, 0.1 actually. 0.10 when you're round.
Is that right? 0.10?
Or 0.099 you could do if you're
All
going
right.
to 3.
So 0.099, so we could say 9.9%, because again, that would be a rate. So we're looking for our rate, 9.9% is what we would keep it as.
The answer is D.
The answer is D? Excellent. You know, that's what I do.
What was that?
We've been practicing. All right, YouTube followers, do you have any other ones online? Any other ones?
It's a live chat.
Okay.
How about number 4?
I hear that. Number 4. All the way from Denver, Colorado, my YouTube follower, number 4.
Really creepy.
What's that follower's name?
His name is
Colorado?
Kalebi.
Love
Kalebi. All the
Kalebi
way
is
from Colorado. Lives at the Denver airport, is what they
You
say.
want some donuts? They call me pretty fly.
Over in Shiana.
Oh my goodness. So, all the way from Denver, Colorado, Kalebi. All right. Kalevada. All right. So, what could I do? Knowing that there's a log here, we want to make sure we condense this down before solving. So, in combining that left side together, yeah, we're going to multiply. So, we'll have log base 2 of x times x plus 3 equals 3 on the right side. So, what about the left side? Talk to me on that. What do I get once I multiply that out?
X squared plus 3x.
Good, x squared plus 3x, and that equals 3. So talk to me on how can I change that log into something that I can solve? I actually just rhymed that. That was pretty good.
You should rap.
Yeah, I don't know what I just said, but I can't say it again. Yeah, yeah. What could I forget what I said, but yeah, anyway. How could I solve this?
Turn it into the other form.
What form?
Exponential.
Exponential. Nicely done. Parker Stevens is live in studios today. X squared plus 3x equals 2 to the third. 2 to the third gives me 8. So I have x squared plus 3x minus 8 equals 0 when I bring that 8 to the other side. So now I need to solve for x within this quadratic, but I can't do it using factoring method. So what method could I use?
Walk away.
Quadratic. That's exactly right.
Good old friend.
That's right. He's a good friend of mine. You know, name's the quadratic. Probably what I'll name my firstborn son someday.
Quad.
And then Raddick Johnson. Yep, you're right. All right, so we'll plug it in the formula. A, obviously put 1 in. B would be 8, or B would be 3, and then C would be -8 on that. Is there anyone that needs me to go through that? All right, my YouTube followers are silent, meaning we are good to go. We're G to G. That's vocabulary, Coach J. Vocabulary, good to go. One of a million things. Any other questions?
Well, on number 4, we don't have to solve that all the way down. Do you want us to get it to a decimal and do all that, or should we just leave it as the quadratic?
I would like for you, that was what we just did, right? Is that one we just did for?
Yeah, for like, you get to the quadratic and the square root isn't happy.
Yeah, you could just leave that.
Okay.
Yeah, if it's not a happy square root, you could keep that as is. We don't want to upset it.
It's not a happy.
Yeah, if it's not happy, you just leave it at its home.
Like I did my
Staying home today.
That's right. Another problem maybe you look at, a couple on the back with some of those graphing ones might be ones that you might want to touch on. I did do the answers online, but it might be one that you want to just take a little look at.
Just take a little look at them.
Just peek a little bit.
Let's take a little look at these materials.
Anybody else that would come in this class would I think they would drop the class like right away. Hannah, what do you think? You think?
I wonder what's gonna happen when you start having kids that you haven't had
I
before.
know, I don't know. I'm gonna be so weird. They're gonna just be like,
They're not gonna understand the progression how we got here.
this is true.
Coach Jay, you give us a good graph on what's a good one?
Yeah, I think my YouTube follower.
The one in Colorado?
Yeah,
Wait, do you have people in this class that watch your YouTube video?
absolutely. They actually do. Yeah, they'll comment on it. Yeah,
That's
they'll say
terrifying.
good things about it, like, hey, you're so funny. You're charismatic
They're
with
definitely not
a little
in other
edgy.
accounts.
They call me the Georgia and Jimmy Fallon.
No chance of that in
The
other
Georgia and Jimmy
accounts.
Fallon.
I believe that's actually Griffin. So I
What do you mean?
think Griffin's the George and Jimmy Fallon. He's more of a talk show host than you. You gotta be tall.
Does he have his own YouTube channel? No.
Probably not. But
No. Does he have a job? No. Does he?
Does he make 10K a year? That's actually probably.
All right, here we go.
Here we go.
Wasting time. Wasting time. Number 16.
You better hope Dr. Morris never finds the second.
This is true. We might have to delete this video.
That's gonna just be a recurring thing from now on.
All right.
It's like concluding.
This
Go
was-
blue, go blue.
This was a bad class to do the video on. All right.
Thanks, Coach.
All right. Hey, check this out. This is very important. I think if there was something on the test in all seriousness that would kind of trip us up, it would be what I'm about ready to go through. So I'm going to take one problem, but I'm going to kind of go over with you a few more, and hopefully that will help you in moving forward to all the other graphing problems. First of all, let's review. If I had something like g of x equals e to the x power, that right there, the exponential graph, would it have a horizontal asymptote or a vertical? Would it be a horizontal or a vertical asymptote?
Yeah.
Horizontal.
It'd be horizontal. Very good, Chris. So we know that it will be horizontal, and traditionally, other than the transformation, it would be at y equals 0. Okay, so traditionally y equals 0. Now, in a natural log, such as this up here, so like ln of x, or you could say log of x, in both of these situations, you could actually take those natural log and logarithmic equations and figure out what the vertical asymptote is. So whereas exponential has horizontal, natural log and log have a vertical asymptote. So both have their specific one that you're trying to solve for. A lot of times people, when they come to it, say, hey, you have to have both, when in reality, exponential only has horizontal, whereas natural log and common log have a vertical. So in this example, because it's natural log, we know we're going to look for a vertical asymptote that is at x equals something. We just don't know what it is. Now, what affects, this is a question for y'all, what affects that horizontal asymptote or that vertical asymptote? Okay, so the 2 in front, this right here, this 2, what does it do for the graph? Yeah, it goes up 2, right? Vertical shift up 2. So it goes up 2. And what about the 3x minus 9? Does it impact with that? To the right, not 9, because we got to set it equal to 0.
To the right.
To the right 3. Very good. So does that make sense, Chris?
Yes.
I set it equal, I'd add 9, divide by 3. So I'd go up 2 and right 3. Up 2, right 3. So if you think about it, if I traditionally have a vertical asymptote at 0, but now the graph goes up 2 over 3, where is the new vertical asymptote at? Where would the new one be? If everything goes up,
It'd just be over 3.
good, it'd be over 3. So if I transformed this over, it would be now x equals 3 would be my new vertical asymptote. So the graph would look, and I think it wouldn't look like this because it's negative out in the front, but it would look something like this where it would be approaching 3 but not crossing it at that vertical asymptote at x equals 3.
Well, it's negative, so would it be? You have a negative ln. Do you see? Would it flip down?
Yeah, because remember, the natural log normally goes this way
I got you.
because it's negative. Again, I don't have to say that,
That'd be fun.
but what would normally go this way because of the negative would then almost look like a exponential graph.
a decay.
Yeah.
Gracious.
So now you got the vertical asymptote.
So you know it is a vertical, right? You understand that? Because it's a natural log or common logarithmic or logarithmic equation, we know there's got to be a vertical. So now, because of the transformation, what traditionally is at 0, because of the transformation of pushing it right 3 and up 2, the up 2 does nothing for me with the horizontal. But what it does do is it does move that or that vertical, moves the vertical to the right 3. So
And it's
now,
3 because it's 3 right there.
because of 3x minus 9, if I set that equal to 0,
Oh.
the transformation would then be, I would add 9, right? Divide by 3.
Right.
My transformation then would be at x equals 3.
Okay.
So the next question is how do we solve for the x-intercept?
What if you have an asymptote at
It's
two, wouldn't it not intersect the x?
Say this one more time.
You have a horizontal asymptote at 2, right?
There is no horizontal for this, right? The only time we have a horizontal is when we have an exponential equation,
Gotcha.
where it's either one or the other.
Gotcha.
Can't have both. Good question, Nick.
I assume because it shifted up 2 that there was a.
And we could test that by plugging. Let's plug in 0 in for y. Remember, if we find the x-intercept, we plug 0 in for y. So say that again.
What was x?
Well, we're trying to find the x-intercept, right? So that's what we're solving for is x.
Got it.
So we set 0 equal to the rest of the equation.
Oh yeah.
So 0 equals 2 minus ln of 3x minus 9. So how could I get x by itself?
Subtract 2,
Yeah, there you go. Thanks, Aaron.
divide by 1.
There you go. Okay. Subtract 2. We know that this right here is negative ln of 3x minus 9. And like Aaron said, we could divide by -1 or change it from what is negative to now positives on either side. So breaking down that ln, what is the way that we can break that down to where it's gone?
Put it to e.
Yeah, we do e to the whatever power, right? So what I can do is I'll throw this down right here on this side. So e to the second power equals 3x minus 9. Because again, what we did was we took e to the second and e to the ln of 3x minus 9. Now, if we did e to the second, then how do we solve for x? That's big.
E to the second plus 9 over 3.
That's it. So e to the second minus or plus 9 all divided by 3. So again, going back to it, finding the x-intercept, plug 0 in for y. And what if I found a y-intercept? Where would I plug 0 in?
For the x.
That's it. That's exactly right. Aaron's right on top of it. Thank you. So again, that's something just to keep in the back of your mind. The big thing, x and y-intercept, that's a big deal. But even a bigger deal is understanding that exponential has horizontal asymptote, whereas natural log and basic and common log have vertical asymptote there. Sound good? I know that was a lot with that one.
Did you divide by -1 on the bottom there? How did it go from negative to plus?
Where is that again?
The
Right
two,
here,
yeah.
the 2's. If I'd subtracted 2, I have negative ln right here.
So you just divide by -1.
That's it. So I'd have 2 equals ln of 3x minus 9. You see that there, Chris?
Yeah. Wait, with the plus in the middle change too? The 3x minus 9, would that have to change? Or
3x minus, no, it can't because it only applies to the ln,
Okay.
right? ln of 3x minus 9 acts as 1. Acts as 1. You see another graph in one down there that you might look at?
Let's do 18.
18, that's a good one. So we know that, do y'all see where the origin's at 18? Number 18? The origin there? So where does the vertical asymptote move?
Right.
To the right one. Does that make sense? So we know it moves to the right one because we know of the shape of the graph. Would it either be a exponential or natural log?
Natural.
Number 18 right now. We're on 18 cooks. All right. We know it's natural log because it. Why? How do we know it's a natural log?
No.
No?
We got a vertical.
Because of the vertical asymptote. That's hands down right there. So we know that there's a vertical asymptote. Therefore, we know right away that it's got to be some sort of log. So we can eliminate A and B just based off that. Then we look and see, is it either C or D? Well, because it moves to the right one, we know which one would it be, C or D. It'd be D because ln of x minus 1 is what transforms that to the right one. That takes that vertical, transforms it to the right.
Do we need a word?
Now that one's pretty self-explanatory.
Just real quick on
Yeah.
16, how do you find y?
Find y as in,
As in you found x.
yeah, you plug this. I actually forgot to finish this. You'd add 9 divided by 3. Does anyone have that?
5.46.
5.46. Okay, so if I put that down right now, my x-intercept is 5.46 comma 0. So that's my x-intercept. To find my y-intercept, is that what you're saying?
Yes, sir.
I plug 0 in for x. So we think opposite.
Oh, you
So
don't plug
I-
in x to find y.
That's it. So it'd be 2 minus ln of -9. Now, can I take the natural log of -9? No. So it's going to come in as error. So what is my y-intercept?
0, 0.
Not 0, 0.
There is one.
There isn't one. Exactly. Nothing. Not there. So you would just say that there is no y-intercept.
Oh, it's because your vertical asymptote is 3. So
That's exactly right. Yeah, because it won't. It will hit that barrier. It'll come close to crossing it, but it won't ever cross it. And so because of that, there's nothing to the left of that x equals 3.
It's just the one thing.
That's it. That's
How
it.
do you know that it does that?
Well, traditionally, and again, it's not exact, right? But traditionally, a natural log will end up going something like that, dotted line. But because it's negative, I know it's going to be flipped. It'll flip over the x-axis because the negative's out in front. So what naturally goes this way now flips to where it kind of looks like an exponential, but it's still approaching that vertical asymptote
I
there.
mean, will we be able to use our calculator for that on the test, or
No, well, you won't, but
so how would I be able to know that it does that when I draw a chart?
yeah, well, you don't actually need to figure out what the graph actually looks like. You have just a basic idea, you'll be fine. So if you know that it normally would look something like this,
Uh-huh.
that when reflected would look reflect over the y-axis. I just did that for you to see that it does have a vertical asymptote.
Okay.
The big deal is that that's horizontal with exponential, and you know that it is vertical with like any logarithmic equation.
All right.
Very good. Also, the domain one, did y'all get that one? I think it's on 15 and 16. No, 15, just 15 there. All right. Tell me on this one, what would be the vertical asymptote? Well, first of all, would there be a vertical or horizontal on number 15?
It's a log, so it'd be
It'd be vertical. How do we know?
those log.
Yeah, exactly. It's common log. So we know it's going to be vertical, and we know it's going to be transformed where? Where will it's traditionally at 0,
To
where
the
will
right.
it be now?
To the right 2.
To the right 2 over
5.
5,
There we
right?
go.
Because if I have 5x minus 2,
We've changed the points.
that's it. 3 of log 5x minus 2. I can then set this equal to 0, and I know that if I add 2 divided by 5, is that right? Did I say 5x minus 2? Yeah, that's right. And then add 2 divided by 5, I know that it will be transformed to the right 2/5. So my new vertical asymptote will be x equals 2/5.
So what you doing?
So that's a great question. If that is my vertical asymptote, can I get anything to the left of that? No, because there's no negative in the inside, right? So it's going to stay to the right of that, like on the previous one. It's going to stay to the right of it. So it's going to look something like that right there. And let's say that this right here is 2/5. So what's the furthest left this graph can go? And what's the furthest right? Infinity. So you could either say in interval notation 2/5 to infinity, or you could say x is greater than 2/5. Whatever floats your boat.
What would your range?
Good question. What would be my range? Good, because why? Good. You said it right. Good, Chris. That's exactly where if you think that way, you're gonna be money. It does not have a horizontal asymptote, so there's nothing that stops it from going from negative infinity to positive infinity.
So for these, do we have to worry about like wrapping individual points, or is it more just finding the asymptotes and the x? Or maybe for like 16 or whatever.
See that one more time, Chris?
Like, do we have to worry about finding the individual like points, or do you want us just to find the vertical asymptote?
That's going to be the main thing, but I will say, like, hey, for the x-intercept, find an x-intercept. So you just plug 0 in for y. I say, hey, find the y-intercept, plug 0 in for x. And just because if you plug it in for x and don't get anything out, that's okay. That just means it'll be an error there. But in your range, it'll go from negative infinity, lowest, to positive infinity. You could say all reals, okay? But sky's the limit, okay? You could really fly. right now. Literally, let's go. You could go to a highway right now. I love that video.
Yeah, on YouTube.
I'd like to apologize.
So everyone needs to go.
I would like to apologize to all of GAC and my YouTube followers for that. Everyone who bought a Coach J T-shirt, I apologize.
He'll probably link it.
It's true. All right. Yeah, I don't know if I can link this one now. We'll see. All right. Any other ones you have, as you see that, you kind of have some questions over? This test, I'll be honest with you, is not the most difficult thing in the world, but it will be multiple choice. Now, some people are like, oh, yeah, that's a great thing. For me, it's not always a great thing. It really isn't. Now, it's going to be different from this test to the exam, because on the exam, I don't have all day in the world because of the time frame where I have to put grades in to be able to grade every problem, whereas this one, I can give you back some credit based on work. But I want you to at least get a little bit of a taste of what it looks like so that you're ready, and I don't just throw cold turkey on you and say,
You could do that.
good luck. I could bring a
We've got
turkey.
plenty of it at Sage.
That's true. I like it. It's good.
It's all awful.
All right, well, I'm looking at any other ones. Y'all see number 8? Which of the following equations is not true? Which ones would you say is not true? First of all, is A true?
Yeah.
Yep, it is. B?
Yep.
Not necessarily. Well, is it?
No.
Oh, yeah.
No.
Let's try it.
No. 1 to the B.
1 to the B
Yeah, 1 to the B,
would be not be.
it wouldn't be. So if we have
Took you a long time to pick up on that.
yeah, we were all saying, I got you. I know. It's log base. Log base 1. That's what it is. Of B equals B. All right. Shoot the 1 over. So if we shot the 1 over, we have B equals 1 to the B power. So if we say, let's plug in a value like 3, that means we say 3 equals 1 to the 3rd, that those are the same. We know anything like 1 to the 3rd, 1 to the 4th is just 1 times 1 times 1. So we know that it'll be 3 equals 1, which will be on the right side. We know that those are not equal. Therefore, we know that that one's the one that's not true.
Question.
Answer,
If-
Steven.
If we were to, if that was to have been correct, and we had to do the D and E, would we select the one of D and E that was correct or the one that was incorrect? Would we select that all three are, if all three of them were true, we have to select that all three were false because it'd be the wrong answer? Since we're supposed to find the one that's false.
Let me tell you.
Wow.
Get a headache.
Wow. I've got, yeah, this is my YouTube follower just came up with a great question. Stefan.
No, Steven's very different from
From-
Stefan.
Oh, yeah,
Don't
that's not what I
compare me
meant.
with that guy.
From Kansas City, Kansas, or Missouri, depending on which side.
Good Kansas City.
That's a great question. D and E would, yeah, that's tricky. It's like almost a double negative. I see what you're saying,
Exactly.
but it's not. So it's B. So we'll go
Yeah.
with B. But very good question. Very good question. How do we feel for this test? We feel pretty good.
I slap your mama good, but yeah.
That's good. We'll end the podcast on that. How about that? That'd be good. All right, signing out, faithful followers. Have a great day. Stay classy.